Hello, everyone, and thank you for joining us today. The webinar will begin in approximately 1 minute. But while we wait, we'd like to let you know about a little activity we're starting, and you can sign up on March 1st. We're going to host a PCB design course. It'll be completely free to participants and walk people who have never made a PCB before through all the basic steps that they need to complete one. You can sign up for free. And as an added bonus, the sponsors are going to cover the full cost for 50 participants, 50. So 50 people will get to make their PCB and have it manufactured for free. Might be interesting if you already know how to make PCBs, maybe suggest it to some coworkers and get them to sign up. With that, it is now time to begin. So welcome everyone. My name is Mark Hughes and I will be your host today. I'm part of the team at Advanced Assembly in Aurora, Colorado. With over 15 years of experience, we are proud to be the original quick-turn PCB fabrication industry leader. I'd like to thank everyone for taking the time out of your busy day to join us for this webinar. For your convenience, we'll record the webinar and post it on our YouTube channel in the next 2 days. Many of our customers asked us how we ensure quality in their orders, so we prepared this webinar to fill that request. We're always here to listen to your needs, so if you have any requests for future webinars, please let us know. As we move through the webinar, please ask your questions in the Q&A box and we will either answer them as we go along or at the end of the webinar. So with that, you've already met me. Let's get to know today's presenter, Jorge Ramos. Jorge is Advanced Assembly's newest employee. He comes to us with over 25 years of experience in the printed circuit board industry. Jorge, tell us a little bit about your story.
Yeah, thank you, Mark, and hello, everybody. Well, I started my career in the PCB world as product engineer, and I was doing failure analysis on flexible boards for inkjet printheads. This was also a time before lead-free solder was adopted, and most of the assemblies used leaded solder. And I joined Advanced Assembly last year because I think it has the right people, processes, and also the right equipment to dominate the market.
All right, well, let's get going. Our presentation today is focused on the quality assurance process. We're here to help you understand how high quality, reliable PCBs are delivered to our customers. We're going to start with an overview of the quality assurance process, talk about our continuous improvement process, look at inspection and tests, and finally finish with a question and answer session. But again, if you have questions as we go along, feel free to ask them. So Jorge, what exactly is quality assurance? What's your job? What do you do on a daily basis?
Well, quality assurance includes quality control. And while quality assurance focuses on preventing defects, quality control focuses on detection and rejection of the defects. And the main principle of quality assurance is, of course, doing it right the first time. So in other words, quality assurance uses strategies to improve the processes and to ensure the quality of the product.
Okay. So in preparing for this webinar, I found a couple pictures off the internet. The one on the left is a prototype PCB for, I think it was some sort of an electrogram, some medical thing. I don't really recall. And the one on the right is a production printed circuit board that came out of a desktop speaker system. So the one on the right was produced 10, 50, 100,000 times and ended up going to market. When you look at those, what strikes you? Anything stand out?
Well, the two pictures are very interesting, but the picture on the left, of course, looks very clean from this perspective. Looking into the microscope will show more detail, but definitely the PCBA on the right got pushed into the production, and I don't know if that was a requirement from the customer, but it looks like a lot of rework and a lot of touch-up on this one. But that is something that I will not let go from my process unless there's a deviation from the customer that wants that assembly to be like that. But no, interesting pictures, Mark.
Always, right? What about, I don't know if you can see if the resolution's good enough, but it looks like there's some brown stuff here. It looks like, possibly additional solder or wires on top of the traces. Do you know
Yeah,
what's going on there?
it looks like a lot of flux and a lot of touch up, probably heat overheated on those locations. Again, a lot of rework on this particular assembly on the right that makes it look very, very ugly from this perspective.
And what's wrong with leaving flux on? I mean, what does that do?
Well, the flux is something that can be affecting the component, the assembly definitely, and with the temperature that can smear, it can create reliability issues on the assembly for sure.
All right, that kind of makes sense. Now I've got to turn the laser pointer off so I can advance the slide. We're stuck. There we go. All right, buddy. So, I mean, you can't do this alone. You want to tell me a little bit about the people you work with?
Yes, we have a wonderful team of people here, and I just need to emphasize that we have the right people because the people that we have has experience, had training, had certifications, but also has the right attitude to make sure that the job we do is with the best outcome and the outgoing quality is better and better every day. We have a group of people that helps with the quality control process and also with continuous improvements on the quality assurance side. So yeah, that's part of the team. Yeah.
That's pretty cool. I like your uniforms there, little blue smocks.
That's necessary to have in this process, by the way.
Oh, yeah? How so?
There's some electrostatic requirements that we need to meet and comply with. The uniforms, as we call them, that has a purpose for discharging and preventing discharge to the components, and everything we have from the floor to the benches, working spaces, and clothing, heel straps, and wrist straps is with the intention on protecting the customer's assemblies. So we protect the components. Some of them are very sensitive to ESD, so we'll do our best to follow those procedures, processes to protect the customer's assemblies.
Huh. You learn something new every day, Jorge. I tell you. That's pretty cool. All right. So I do some design, and when I design, I see some standards, IPC 2221, it's been replaced by 2152, it doesn't matter. But I really don't see anything outside of that because all of the IPC standards are locked behind a paywall. So can you tell me a little bit about IPC J Standard 001 and IPC 610A?
Yes, J standard is the operation of soldering, basically, and 610 is the inspection criteria to determine pass or fail on the assemblies. And that includes a lot of standards, but basically everybody refers to this as J standard or IPC A610. But between the two of these, this is how you run the process on the left, J standard, and how you inspect what you did with IPC A610.
Is that anything as a designer I should care about? Should I buy those standards to better understand them?
Well, there's definitely different criteria between the standards, like class 1, 2, 3, different requirements for solder field and different requirements that we need to meet. It is important that we get the right requirements from the designers and the customers, so we don't, I mean, we build properly according to what the requirements for the assembly is. Let's say, for instance, the field requirement for solder in one standard or one class is different than the other one. Yeah, the picture on the upper left. So the minimum field requirements for class 1, 2, or 3 is different. So IPC, which is upper left on your screen, the pictures, which is the visual aids that you have on IPC A610, versus J standard on the bottom right, which is basically the words that describe how to run the process. the two of them matches, but how to inspect, you need those visual aids to determine pass or fail, go no go on this particular one. But yeah, the classes are different, the requirements are different, and we need to get that information from the customers to build appropriately.
So you inspect every single board?
We do inspect every single one, yes. And we build as per J standard, and we inspect as per IPCA 610. Yes, the answer is yes.
Wow. All right. That sounds like a lot, buddy, but good for you. All right. You also said you're the customer care representative. What does that mean?
What we do in our quality control department, and when we check the assemblies before we ship them to the customer, is we look through all the documentation that they supply to make sure we act like the customer sitting in front of the assembly. What the customer will see on their incoming inspection for these assemblies, that's the position we take on the outgoing inspection. Being like the customer doing the inspection and making sure everything meets the criteria stated in the documentation supplied.
All right. Can you tell me a little bit about what we're looking at on the screen there, that picture?
Well, we're looking at the assembly that we have underneath the camera, and there's microscope through all the process. We utilize microscope where only one person can see what's on the screen, but we also have these tools where you can display that on the screen to share and show multiple people findings, inspection criteria. This is very useful for standardization of criteria and show and tell quality potential escapes that we may have. So that's what we utilize this for.
All right. So I also see you sitting there at the bench, and it looks like you've got an ESD wrist strap on.
Yes, again, at any given point, you are carrying a lot of voltage in your body that if you don't discharge or ground yourself, you have the risk of transferring that to the assemblies. Same thing that happens when you go to a store and grab a cart, like you go to Walmart, grab a cart. Sometimes you feel that electricity flowing from your body to the cart. That can damage components on the assembly. So this is just to prevent that to happen.
All right. What about your continuous improvement process?
Well, in our continuous improvement process, we have a lot of methodologies. Continuous improvement, or Kaizen, how many people know this, is for identifying opportunities to improve the process and also to reduce waste. And my team is working every day on identifying what is critical to quality to monitor and improve those processes through different quality methodologies like statistical process control and all that.
So this all sounds like a ton of work, Jorge. Why did you get into this? What makes this exciting for you?
It's very interesting. Once you have the you need to define a process that you like to improve, and through all this improvement process, the accomplishments and the results is very rewarding because you define, you measure, you analyze, you improve and control a process, and then you go back to the beginning and jump into another process. So it's very exciting because you get results, tangible results. So you can measure this and feel that and have evidence of what you're doing going up or down, basically.
Oh, all right. So maybe you can walk us through a few of the tests that you use on a daily basis. What do you do in visual inspection?
Well, visual inspection, and going back to IPCA 610, we basically take that standard and review from that assembly that is in front of us and make sure that we're meeting that standard and the customer requirements. So on visual inspection, we inspect for rotation, polarity, solder, presence, and all the different things that the IPC calls for, we do that on visual inspection, which of course is done by people.
All right. Hey, I've got a question for you. Whenever I've designed a board, I would say, on average, of all the boards I've designed, 50% of the LEDs have always been put in backwards. Not by advanced assembly, of course, but is that something you guys can catch, or is that kind of too small a detail?
No, that's something we're able to detect, definitely. Yeah, on the visual inspections and or the inspections that we have, but basically from the placement on the SMT operation, that's the first step and the first check we have. So yeah, that's something we'll check for, look for, and try to prevent that to be with the incorrect polarity, definitely.
What's the smallest size component that you can inspect with the microscopes?
Well, we have very tiny components, 10005s, and those are very tiny that most of the times we need to utilize our AOI inspection to help us with the identification on components. But yeah, very tiny size.
All right. Let's get on to the AOI, Automatic Optical Inspection. What is that? How does it work? I mean, what is that looking for?
Well, the AOI, of course, is a machine and never gets tired, never calling in sick. So you get out of that machine a lot of inspection speed and consistency. You also have accuracy and reliability for the inspection process. So basically, it's a piece of equipment that helps on the visual inspection and helping determine certain parameters on the assembly.
Okay. How fast is it, would you say?
There are different speeds, and we have 3 AOIs in the process, but that'll depend on the number of components, the size of the assembly, but I can tell you they are faster than humans and more accurate.
I imagine. You have to be looking for different things as a human, because you guys still do the visual inspections, but then you've got AOI. What are some things that humans pick up that AOI doesn't, or that AOI picks up that humans don't?
Well, mainly on the legend on the components that you can see on the image on the bottom. Those numbers like 2201 on a small size component is very hard to see on the microscope through a human trying to identify that. But the AOI has a capability to look for that, and not only that, but the rotation of that component. So it looks for that detail that sometimes human can skip. The machine has more reliability and consistency on identifying those.
Huh, all right. All right, now onto my favorite machine in all of advanced assembly, the 3D X-ray. Dude, you got to tell me, you ever X-rayed your phone?
I have, yes.
Nice.
Yes.
So tell me a little bit about this bad guy.
Well, the 3X X-ray, it's not only an exceptional piece of equipment that is not only very cool to drive, but it's necessary to inspect leadless components like BGAs, and also for through-hole solder field, just to mention some applications. But yeah, you can go any angle on this one and rotate however you like to get the details that you need to do a proper inspection.
Is this something that customers can utilize to improve their design, or is this something that customers can order, or is this something that we do on all our boards?
This is something that we check in all of the leadless components. Let's say a customer has VGAs on their design. They don't need to pay extra for this inspection. This is built into our process and inspection.
That's cool. Can we send you things to X-ray and you send us pictures back?
Definitely, yes.
Like as big as a cat, or
We're probably cool, but yeah, we don't do that.
Okay, just checking. I figured I'd ask. All right. Well, we actually went through that pretty quickly, so we have a ton of time for questions from our audience. And we do encourage you to ask. We had one so far from William Ingham, and he asked, are the slides available? The answer, William, is yeah. Just email me, mhughes@aapcb, and I will send them to you. What else would you guys like to know about quality control? I mean, you're already taking the time off for lunch, sitting there with your turkey sandwich, maybe a little bit of lettuce and cheese. What do you want to know about quality? Oh, come on. There's got to be a question out there. There's got to be a question out there. It looks like we have a hand up, but I don't know where it went. It disappeared. Okay. Oh, here's a question from Dan Ballantyne. He asks, what about conformal coating? What can you tell us about that?
We don't do conformal coating here in-house, but we have a third-party company that we work with to meet that requirement. So if there's a design that requires conformal coating, we can supply that, but it's a third-party company that we utilize for that service.
And what are you looking at as far as quality goes in the conformal coating? I guess another question is, why do engineers use them?
Well, conformal coating it has its own challenges and requirements from the customers. So we don't basically deal with conformal coating, and but we make sure that the requirements are met when they are doing that process.
All right. Brian Beaufil asks, what kind of design quality checks and recommendations do you provide?
Well, the quality checks that we have is every step of the process, we have quality control. And on every step of the process, we look for defects in or reliability of the assembly. So it's a huge list of processes that we check. It's a huge list of processes that we have quality control implemented. But the most important one is at the end through the outgoing inspection. That's the final check that we have.
All right. What types of failures or problems do you typically see with heavy copper usage? Heavy copper boards?
Well, heavy copper board, it's always a challenge with those because we don't do functional test, and the majority of the reports that we have is inner layer shorts on failure modes. But here on the assembly process, if we have through hole parts, heavy copper needs to be preheated to make sure that the solder flows properly. And that's probably the biggest challenge when we're doing like selective solder on heavy copper boards.
What about like a vapor phase reflow versus convection oven? Would that be of any use?
Vapor phase allows you to have lead voids in the components, so minimizes the voids failure rate. Basically, that's the main advantage of that.
All right. Hassan Matni has been very patient. He would like, he says, can you tell us about flexboard testing steps?
Well, again, we don't do any type of testing here in-house. We do inspection per IPCA 610. So whatever the standard calls for, we do that, unless in rare occasions where the customer sends test equipment, we have no capability for doing any testing.
I'm guessing Hassan was asking if the inspection processes for flex and rigid flex differ from the inspection processes for just simple rigid.
Well, it's a little bit different in the process, but basically looking for the same things per IPCA 610, same standard.
Okay, all right, buddy. We've got some questions for you that we actually did entire webinars on regarding vias, right? So the first one, and these might be from the same person, it's an anonymous attendee on my screen. So sorry, I don't know your name. But it says, under BGAs, do you prefer tinted vias, solder mask encroached vias, or plugged vias?
Well, plug bias is definitely the prefer there because when you have a BGA and you have a pad that has a via on it, well, the solder connection, it's going to be a challenge, definitely there.
So anonymous attendee, we have an entire webinar on vias, and that covers solder thieving. If the solder is not masked, or the solder mask is not there to kind of create a dam, the solder will actually go and flow into the via, and then you're left with insufficient solder, and you get a really bad connection that can cause your board to fail. Same thing under thermal pads, but I think we have that in a next question. Let's see. Do you know how board houses plug vias? So I'll take that one if you don't mind, Jorge. There's a few different ways. The first cheapest way that they can do it is just to tint. And up to, let's call it 50 mil diameter via hole. You can probably tint over that with some success. But again, that's not plugging, and tinted vias can fail. The next thing you can do is an LPI solder mask fill. So you basically just inject or squeegee LPI into the via holes to plug them up before you do the rest of the LPI coating and put it in the oven to bake. Next up, you've got an epoxy, just a simple epoxy filled via that is then plated over. And if you really want to get fancy, you can do an epoxy filled with a thermal paste, something to increase the conductivity. Although, unless you really have a ton of heat going through your boards, you probably don't need to pay for that expense. There was a book put out by Douglas Brook and John Adams, no, the last name was Adams, where they looked at via temperature over traces, and they found that the via temperature tracks very closely with the trace temperature above it. So you can often get away with just an LPI fill or a simple non-conductive epoxy fill. So I hope that answers your question. It might be more than you want to know. And if you want to check out our YouTube channel on vias, you'll get a whole webinar on that. All right, Jorge, next question from Anonymous. Oh, actually, we've got one from Dan. I think Dan first. Dan asks, do we offer DFM and DFA services?
DFM, well, yes, we do. But that is something, again, that through the whole process of quoting, that's something that needs to be reviewed. If we have something special for the engineers, that's something that needs to be checked there.
So we've got a partner company, Dan, called Royal Circuit Solutions in Hollister, California, and they do free DFM services for our customers. So at the quote stage, before you pay any money, you can send us your design, and we'll put it through their DFM service. And then internally, we have a DFA, a design for assembly. So design for manufacture is, can we make your board? Design for assembly is, can we put parts on it? And we do offer those services at the quote stage. You don't have to pay for them. If you just want to come and see us and use them and then go run somewhere else, that's okay with us. Just do it. It's cool. Anonymous attendee. When using a no clean flux, how do you verify all the flux is cured under parts? How do you verify that rework flux is removed from circuit boards?
Well, that's part of the visual inspection process to make sure we don't have flux under the parts and or the PCB surface. It's totally standard in our process to look for that.
Is there anything that I as an engineer can do if I get the board maybe from another house that isn't as careful? Is there anything I could do to look for that, or no?
But yes, a visual inspection, but you need to utilize certain magnification. And if you cannot see under the part, probably you need to take that through the X-ray machine and do a contrast check to see if you have the shadow for the flux or something else that you can identify.
Why is it important to get that flux off again? I know you kind of mentioned it earlier, but it's no clean. Why can't I just leave it on my board?
Well, it looks like for some applications, it's very important to have the PCB clean, totally clean from flux and other foreign substances or residues, because that can create a reliability issue either with heat or corrosion. Uh, every design is different, so but basically those two are the main ones.
Okay, anonymous attendee. This guy's got some questions for you, buddy. I tell you, putting you through your paces. His question is, do you pot any components onto PCBs like fuses?
Do we pop?
Pot, P-O-T.
Oh, okay. Well, again, if we do place components, we don't have the capability of testing components, but we can install anything on the PCB on the process.
So I think when he's referring to pot, he's talking about, that white epoxy glue thing that you use to hold something in place when it doesn't have enough mechanical.
Correct.
Yeah,
Yes.
okay.
And again, if it's part of the requirement that we need to do that process or apply a certain epoxy, we just need the specifications of what the adhesive that we're going to apply is, and cure time and all those things that are important for us to consider when we're doing something special to it. But yeah, definitely we can do anything with the assemblies, including that, and we do that on a regular basis, by the way.
Okay, that's pretty cool. All right, do we have any other open questions from anyone out in the audience? We're happy to take them. We've got a few extra minutes. Oh, anonymous attendee again. This guy's got your number, Jorge. I'm telling you. It says, back to washing off no clean flux off boards. Do you routinely wash no clean flux boards?
Well, again, it's part of the whatever requirements we have from the customer. If it's a no clean or a true no clean or a wash process, we need to enforce that, and we have the documentation that shows how to run that assembly. And whatever it says there, we do it. So if it says wash, we wash it. If it says do not, we don't. And for some of them, we'll also take pictures and show the customers, you're requiring this, but it looks like this. Do you want to change the process, or do you want us to ship it like as is? And sometimes it comes with a phone call and a review with the customer, just to make sure that what we're delivering is what they expect, to prevent surprises on their incoming inspection.
Interesting. Okay, but you said something in that answer at the very beginning that now I have a question about. You said if it's clean or if it's true no clean. What's the difference? Have I been lied to all my life, Jorge?
We have identified some processes that we need to call them true no clean, just to make sure we don't watch them at all. And there's sometimes the design has some processes where the customer wants to wash the assembly after SMT, but they don't want to wash that after placing a true hole part, because probably that's an after wash or no wash part. So we need to have the controls here in the process to make sure that we wash at the beginning and we don't wash at the end. So, or don't wash at all, right?
Okay. All right. From Dan Valentine to you. For customer rejections, do you conduct a formal corrective action? For internal rejections, do you conduct a formal corrective action?
For both of them, we have a formal corrective action. We have the internal ones and we have the externals. For every complaint that the customer has that ends into an RMA, well, we need to do a corrective action. Now, some customers require that corrective action only without returning assemblies because they want root cause analysis. But yeah, here in advanced assembly, every occurrence has and demands a corrective action.
Do we get a lot of those?
From the customers?
Yeah.
Well, again, most customers, when they have a return, they ask for a corrective action. So yeah, when we have a return, usually we have a corrective action or a SCAR requested from them.
Okay. All right. Does that work out for you, Dan? Let me know if you need a follow-up on that. From anonymous attendee, how will the presentation be available? Via web or emailed to us after the webcast? Shortly after the webcast, one of my colleagues downloads it, trims off the beginning because I've got about 15 minutes of just waiting for people to log in, and then we upload it to our YouTube channel. I don't know if we email this to you as well, but if you check out our YouTube channel or our blog on our website, you'll see it within the next day or two. So I hope that helps. What is the address of your YouTube channel? Oh, these are the hard questions, anonymous attendee. I want to say we are SMT Assembly, but the easier place to go is, and I'm going to type this for you now too, but if you go to aapcb.com and click on blog, we post links there too. That way we'll definitely get you there. All right. How do you check board cleanliness?
Well, we only have the visual inspection to check for that. And that's the only way to do this. So we take it to the microscope and we check for presence of foreign substances or, flux residue or cleanliness overall.
Okay. Anonymous attendee again, is certificate of completion available? So I'm going to ask you to clarify that question. Do you mean a certificate of completion that you've watched the webinar, or is this a quality control aspect? Jorge, do you know?
Well, they're probably referring to the CFCs. Yes, if it's the CFC, we supply that with every batch of assemblies that we deliver to the customers.
Okay. Okay, so anonymous attendee again, and I'm going to spell these out because I'm unfamiliar with these. It says you don't do a ROSE test or SIR for board cleanliness checks. So that's ROSE test or SIR.
ROS test. Well, again, everything we do is just visual inspection. We don't do any type of test. I know they're referring to certain tests for cleanliness, but the only thing we do is just visual inspection.
Okay, so it looks like the answer to that is no, anonymous attendee, but if you want to follow up with an email or something along those lines, if it's something that you require, it's something that we can find a way to get done one way or the other, even if we have to send it out and contract it to a verification lab. I mean, it's extra work, but if it's something you need done, it's something we will do. I'd be interested to know what kind of work you're doing. Kind of sounds like you've got a lot of fun projects going on. All right, any other questions? So if you look in the chat, you will see that we've got a link to our YouTube channel now, posted from Lisa Holmes. It's youtube.com/user/SMT assembly. We will also email you all with a link to the recording. So there we go. We've got an answer for that. Anonymous attendee wants to know credit for watching web or IPC MIT credit. Anonymous attendee, I just work here. I don't know. I'm just a pretty face behind this camera. I don't have an answer for you there. And since you're registered under anonymous, we've really got no way to contact you. So the best thing you can do, if you want to email me at mhughes, MHUGHES @aapcb.com, I could follow up and I could find out with you from my boss. My job is simply a webinar host, but I'm more than happy to follow up with you to see if we can find out about that. Sound good? All right then. Jorge is available at jramos@aapcb.com or 1-800-838-5650. So jramos@aapcb.com, 1-800-838-5650. If you have any questions about quality control, feel free to reach right out to him. If you have any other questions, if you require a DFM or a DFA check, and we do those for free, just connect on our website and with any one of our salespeople, and they can run those for you and usually get them back to you within a day or so. I know we're pretty slammed right now picking up all of the offshore accounts, but our typical turn time on that stuff is about a day. It's pretty quick, usually same day, and it's really not a big deal. Even if you want to go use somebody else, you're more than welcome to. Anonymous attendee is still asking questions, Jorge.
Okay.
So he wants to know what the VIA posting is. So I'm going to pull that up for you if I can. So give me just a second to chat. Is there anything you want to say as a closing remark, Jorge?
No, just appreciate everybody's time. Thank you very much.
All right. Give me just 1 second there, anonymous attendee. It might be on our, anonymous attendee bailed. That's not good. Lisa, do you happen to have the link to the VIA topic that we did with Sebastian? Was that under our DFX and DFA? Okay. VIA person is still here.
Yes, I sent the link already to him.
Okay, so anonymous attendee, I just sent you a link to that. Hopefully the audio didn't blast through to everybody, but it's actually titled Learn About PCB Vias, and it's at our partner website, Royal Circuit Solutions. That's why you had trouble finding it. So let me add that to the chat. All right, with that, I do have one last final announcement for everybody. If you are at all interested in learning how to make a PCB, we are starting a free PCB design course where everybody will design their own conference badge. We're going to give you the schematic and walk you through all the steps and everything you need to know to make your first PCB design. The course is 100% free. There is very little advertising. Really, the only thing you're going to see are the same logos that you see here. No ads are getting blasted at you or anything like that. And 50 people will be randomly selected to receive a completely free board. We're going to manufacture it for you. We're going to assemble it for you. Should be a fun experience for everybody. So even if you already know how to make boards, maybe you want to send some other people in your company our way or some friends or family, we're happy to have you 100% free. You can't beat free. Free's good. And with that, I would like to end this presentation and thank everybody for coming. It's been a lot of fun. I learned a lot, Jorge, so thank you so much for doing that. And we'll see y'all next time. Have a great day. Bye. Stop.